This video discusses trigonometric functions of any angles. A reference angle for an angle theta, written theta prime, is the positive acute angle made by the terminal side theta and the x-axis. I don't tend to use that prime notation. I know that some textbooks do, so I like to talk about it, but I usually don't. You'll notice in that definition that it says that your reference angle is a positive acute angle made by the terminal side of theta and the x-axis. So basically, we're creating a right triangle on the Cartesian plane by dropping a perpendicular from the terminal side of theta to the x-axis. So let's practice finding some reference angles. So we want to find the reference angle for 7 pi over 4. So let's put this on our unit circle on the Cartesian plane. 7 pi over 4 is right here in our fourth quadrant. And we're going to drop a perpendicular to the x-axis. And our reference angle is going to be this angle here. It's always going to be acute, and it's always going to be positive. So how much further did we have to go from our angle 7 pi over 4 to get to the x-axis, which would be a full 2 pi? So we'll take 2 pi, subtract 7 pi over 4 from that, getting a common denominator. We get that our reference angle is going to be pi over 4. And you want to keep it in the same unit as you're given. So if you're given radian, give your answer in radian. If you're given degrees, give your answer in degrees. So let's do the next one, 665 degrees. Well, you'll notice that this is more than one rotation of a circle, right? Because it's greater than 360. I would start by finding the coterminal angle. So we just subtract 360 over and over again until we get something between 0 and 360. And we only have to subtract 360 once here. So our coterminal angle is going to be 305 degrees. So now we want to get that on our unit circle. I know down here at the bottom is 270 degrees, and this is 360 degrees, so we're somewhere in between there. So there's our angle. I guess it really should go around twice, 665. And now we're going to drop a perpendicular to the x-axis, and it's always the x-axis, never the y-axis. And we want to figure out what this little angle here would be. How much more do we need to go to get to that 360? We were at 305. To get to 360, this is going to have to be 55 degrees. So there's our reference angle for 665 degrees. Next, we want to find the exact values of the 6 trig functions for theta equals negative pi over 3. This is just an extension of what we've already learned about the unit circle. This is really the only way that I find values on the unit circle. I do not memorize the unit circle. I find the reference angle, and I use my 30, 60, 90 triangle or my 45, 45, 90 triangle every single time. I really encourage you to watch my videos on that so that you're not memorizing so much. So I'm going to draw up my angle of negative pi over 3. It's going to put us here in the fourth quadrant. Now, honestly, when I'm finding values on the unit circle, I do think of everything in terms of degrees because I'm referencing my special right triangles, and those are all in terms of degrees. So I'm going to drop my perpendicular to the x-axis. That angle of negative pi over 3 is the same as negative 60 degrees. So that tells us that our reference angle right here is 60 degrees, and that's going to make this angle 30 degrees. So here we have a 30, 60, 90 triangle, and we're going to use what we've learned about inscribing triangles in the unit circle to find our sides. But we know that our r is always 1, our hypotenuse. The short side of a 30, 60, 90 triangle is 1/2, and the long side of our 30, 60, 90 triangle is square root of 3 over 2. And remember, the sides corresponding are always across, so the long side is going to be across over here. Square root of 3 over 2, but since we are in the fourth quadrant, that square root of 3 over 2 is going to be negative because it's a negative y direction. And now we just need to write out our 6 trig functions. Sine of negative pi over 3, we know sine is y over r, so that's going to be a negative square root of 3 over 2. Cosine of negative pi over 3, we know cosine is x over r, so that's 1/2 over 1, which is just 1/2. Tangent of negative pi over 3, well, that's our sine divided by our cosine, or you can think of y over x. Either way, that's going to be negative square root of 3 over 2 divided by 1/2. So we'll multiply by the reciprocal here. 2's cancel. Tangent of negative pi over 3 is just negative square root of 3. And once I get these 3, I just flip them over to get the other 3. We know that they're reciprocals. Cosecant of negative pi over 3 is going to be the reciprocal, which is negative 2 over square root of 3. This will need to be rationalized, multiplying top and bottom by square root of 3 over square root of 3. Cosecant of negative pi over 3 will be negative 2 square root of 3 over 3. Secant of negative pi over 3 will be the reciprocal of cosine. That's just 2. And then for cotangent of negative pi over 3, we have the reciprocal of tangent. This will also need to be rationalized. Don't forget that negative in the bottom. We get negative square root of 3 over 3. And there are 6 trig functions. Next, what we want to do is go in the opposite direction. I think this is the harder direction. Find all values of theta if theta is in the interval 2 to pi. So here we have cosine of theta equals square root of 3 over 2. So what I think to myself is that square root of 3 over 2 is the long side of a 30, 60, 90 triangle. So I'm going to draw that out. Cosine is the x, so the x direction is the long side and then the short side, and then we have a triangle. Since x is the long side, that means that the angle opposite that is our large angle, which is going to be the 60, giving us a reference angle of 30 degrees. Now, cosine is positive not only in the first quadrant, but cosine is also positive in the fourth quadrant. So we're going to have a sister triangle of the same shape in the fourth quadrant also having a 30-degree reference angle. So now we just need to state what those two angles are in radian. 30 degrees equates to pi over 6. So for the blue one, theta equals pi over 6. And then for the red one, that's going to be pi over 6 shy of 2 pi. So that's going to be 11 pi over 6. So we get two answers here. Let's look at our next example. Cotangent of theta is equal to -1. Anytime I see a 1 with tangent or cotangent, since they're both the ratio of sine and cosine, to end up with a 1, that means that sine and cosine have to be the same value. That happens in a 45, 45, 90 triangle, that both sine and cosine are square root of 2 over 2. So I'm thinking to myself, all right, that means that I'm going to have a 45, 45, 90 triangle. Since cotangent is negative, that means one of them has to be positive and one of them has to be negative. So the quadrants that sine and cosine are opposite happens in the second quadrant. So we'll have a triangle here, and it's going to be a 45, 45, 90. And it also happens in the fourth quadrant. So again, here we're going to have the sister triangle, another 45, 45, 90 triangle. And now we just need to figure out what those two angle measures are in radian. So starting with our blue one, 45 degrees equates to pi over 4. So that's going to be 3 pi over 4 for the blue one. And I think of it as being pi over 4 shy of pi, and kind of just subtract backwards. And then for the red one, we're going to be pi over 4 shy of 2 pi. So subtracting there, we're going to get that theta is equal to 7 pi over 4.